Welcome to A-level chemistry lessons. In this video, we are looking at chemical energies. By the end of this video, you will be able to define enthalpy and explore the common standard enthalpies. Let's define enthalpy. Enthalpy is the heat content of a system. Since the enthalpy change of a reaction is roughly equivalent to the amount of energy lost or gained during the reaction, enthalpy can also be defined as the total chemical energy inside a substance. When chemical reactions take place, changes in chemical energy take place, hence the enthalpy changes. An enthalpy change is represented by the symbol delta H, where delta simply stands for the change and then capital letter H simply stands for enthalpy. An enthalpy change can either be endothermic or exothermic. An endothermic enthalpy change is one in which the energy in the form of heat is taken into the system, and hence, because the energy is being taken into the system, it is going to be positive. We also have a situation where the energy is taken out of the system. If the energy is being taken out of the system, it is going to have a negative charge, and therefore it is going to be exothermic. Enthalpy change of reaction. To fairly compare the enthalpy changes in enthalpy between reactions, all reactions should be carried out under standard conditions. The standard conditions are a pressure of 101 kilopascals, a temperature of 298 kelvins or 25 degrees Celsius. Each substance involved in the reaction is in its normal physical states, which is solid, liquid, or gas. To show that a reaction has been carried out under standard condition, we use this symbol to show it. For example, if I write delta H and this symbol, I can read it as the standard enthalpy change. If it was just delta H, I would have just said enthalpy change. But the moment I include this symbol here, then it is going to be read as the standard enthalpy change. Standard enthalpies, these are enthalpies that are as a result of reactions that are carried out under standard conditions, which is the 101 kilopascals and the 25 degrees Celsius, or simply 298 kelvins. Standard enthalpy change of reaction is the first one that we are going to look at. The standard enthalpy of a reaction is the enthalpy change that occurs in a system when a matter is transformed by a chemical reactions under standard conditions. We can look at this reaction here that has been carried. It's just a common reaction, and a reaction can either be endothermic, meaning it is taking in heat energy from the surrounding into the system, or it could be that the system is releasing heat to the surrounding, and therefore it would be exothermic. So these are the common changes, as long as these reactions are being carried out under standard conditions, which is a temperature of 25 degrees Celsius and a pressure of 101 kilopascal, then it is going to be considered to be a standard enthalpy change of reaction. Let's look at the standard enthalpy change of solution. The standard enthalpy change of solution is the enthalpy change when 1 mole of a substance dissolves to produce an infinitely dilute solution. So it's about changing the state. Is it changing maybe from solid to solution? Then you can tell that there's a dilution that has happened here. An infinitely dilute solution is a theoretical construct that cannot exist, and scientists must use a very large body of water as an acceptable substitute for an infinitely large body of water. The standard enthalpy of solution can be a negative or positive value, and so the process of dissolving a substance is either exothermic for some substances and endothermic for others. Here we have an example of to illustrate what we are talking about. We have a solid here of sodium chloride. We dissolve it, it is going to dissolve into its various components. So the energy change that is involved in doing this is what we are calling the enthalpy change of solution. And this is only true when it is being carried out at a pressure of 101 kilopascal and a temperature of 298 kelvins or 25 degrees Celsius. Let's look at some examples. The following equation describes the enthalpy of solution for the dissolution of sodium chloride in water at a temperature of 25 degrees Celsius. So here we have our standard temperature, meaning the enthalpy change that we're going to get is a standard one. Sodium chloride being changed to sodium cation and chloride anion. So here the enthalpy change, the standard enthalpy change of solution is a positive value. Therefore, in this scenario, this one is going to be an endothermic reaction. The standard enthalpy of solution is clearly an endothermic reaction because the system of atoms must absorb energy for the reaction to happen, and because the enthalpy of the product is higher than the enthalpy of the reactant. However, the standard enthalpy of solution of sodium hydroxide in water at room temperature at a temperature of 25 degrees Celsius is a negative value. Therefore, it is exothermic. These two examples are just here to emphasize the point that the enthalpy change of solution can either be endothermic or exothermic, depending on the situation. Standard enthalpy of hydration is another type. Enthalpy change when 1 mole of gaseous ion is dissolved in water at standard conditions to form an infinitely dilute solution is called hydration energy or hydration enthalpy. It is represented by delta H height. Delta H height. This enthalpy is exothermic. Please take note, the enthalpy change of hydration is exothermic. Therefore, the value is going to carry a negative charge. It is going to carry a negative charge. Let's just look at an illustration here. Please take note that there is another concept that we're going to learn, which is known as lattice energy. It is just the opposite of hydration energy or enthalpy change of hydration. So we have the gaseous ions here. You add water, so you add water to the gaseous ion here. We add our water, which is H2O, and then we're going to have hydrated ions. So the energy that is involved, the energy change that is involved here is what we call the standard enthalpy of hydration. Let's now look at the standard enthalpy of neutralization. Just to remind someone who may have forgotten, we know that a neutralization is simply a reaction that takes place between an acid and a base, and this should be able to produce a salt and water only. So this is what a neutralization reaction is. In this illustration, you can see that 500 cubic centimeters of hydrochloric acid was reacting with 500 cubic centimeters of sodium hydroxide. So this is actually going to produce water, because remember, if we are writing this one, we're going to have HCl as an aqueous reacting with sodium hydroxide, which is also an aqueous. So to form the salt here, we know that the last part of the acid and the first part of the base is what gives us the salt. So we're going to have sodium chloride and we're going to have our water. So this is what we're going to get as the product. Okay, this is what we're going to get as the product. Now we are saying standard enthalpy change of neutralization is the enthalpy change when 1 mole of water is formed by reacting an acid and an alkali under standard conditions. Now we know that an acid and an alkali are able to produce a salt and water. So the energy that we are interested in is the energy that is responsible for producing 1 mole of this water molecule. The reaction is always exothermic since heat is given out. So please take note, neutralization reactions are exothermic because heat is given out. Standard enthalpy of atomization. This is the change when 1 mole of gaseous atoms is formed from its elements under standard conditions. So 1 mole of gaseous atoms is formed from its elements under standard conditions. The enthalpy of atomization is the enthalpy change that accompanies the total separation of all atoms in a chemical substance. Let's look at an example using methane. So methane here is a combination of carbon and hydrogen. So if we talk about the atomization here, we are saying, can this molecule or compound be separated into its atomic components? So we have the carbon atom and the hydrogen atom. They should be on their own. That's what atomization entails. So separate the carbon and the hydrogen. So here, that's why we are having carbon and 4 hydrogens. So meaning these have been what? Atomized. Now, the energy change that is involved in separating these things is what we are calling the enthalpy change of atomization. And if it is carried out at a temperature of 298 kelvins and a pressure of 101 kilopascal, then it qualifies to be a standard enthalpy of atomization. So for diatomic molecules, the enthalpy of atomization is equal to the enthalpy of bond dissociation. Please take note of this one. It's going to be very important. Remember, this is the first series of chemical energies. So as we proceed, we might need all this knowledge. We are going to need all this knowledge to perform calculations and understanding of other things. So for example, if we are talking about the atomization of hydrogen, which is diatomic by nature, then we are going to see that this hydrogen has to be broken because we have 2 of them, so it has to be separated. So here, as an atom, we're going to have 2 atoms of hydrogen, which give us 1 molecule here. All right, let's look at the standard enthalpy of combustion. The standard enthalpy of combustion is the enthalpy change when 1 mole of substance burns completely in oxygen under standard conditions and standard states. Now we know that most of the combustions that we have, especially if you are combusting any carbon-containing compound, then it always produces carbon dioxide and water. Okay, so combustion, we are saying standard enthalpy of combustion are used to compare the amount of energy that can be obtained from different types of combustible fuels. There are some fuels that produce more energy compared to others. So the standard enthalpies of combustion are very useful in determining which one produces a higher amount of energy. Instead of carrying out an experiment every time you want to use a certain amount of energy, these things have been predetermined, and therefore if you have that knowledge, it can be quicker for you to do whatever it is that you are doing. The standard enthalpy of combustion is always exothermic because energy is given out. Please take note, this is going to be very important. Always exothermic because energy is being given out. So this is just an example of a combustion reaction in which methane was being combusted completely to produce carbon dioxide and water. In this process, energy is also given out. So let's look at these compounds that we have. So in terms of the enthalpy change of combustion, this one is ethene, which is able to produce this energy in kilojoules per mole. Hydrogen is able to produce this energy in kilojoules per mole. And then we also have ethane, which also produces this amount of energy in kilojoules per mole. So having this knowledge here tabulated somewhere in literature sources, it could help us to make certain decisions without problems. Let's also look at the standard enthalpy of formation. The standard enthalpy of formation is the enthalpy change when one mole of substance is formed from its constituent elements in their standard states and under standard conditions. This is going to be very important as we do the calculations of lattice energy. So the more negative the standard enthalpy of formation for a substance is, the more stable that particular substance is. Let's just try to give an example of what we mean by enthalpy, standard enthalpy of formation. So we have hydrogen, and its natural state is gaseous state. Oxygen also has got a natural state of gaseous state. So when we combine these two to produce a molecule of water, then the energy change that is involved here, that is what we are calling the enthalpy change of formation. Now, this one is going to be the first step as we are dealing with the Bond-Haber cycle. So you need to understand this knowledge here. Let's look at the summary of what we've looked at. I think this is the table of summary. You can just pause, look through, and concretize the knowledge that you have looked at in detail so far. So we have these things that have been summarized in this table. Thank you so much. Please be on the lookout for the next series under chemical energies. Thank you.